Identity Hakim. I'm from Saudi Arabia and I'm a senior at Arkansas Tech University in the field of mechanical engineering. Today I'll be talking about the wireless control of the DC motor. In general, the wireless term is used for any computer network where there is no physically wired connection of the system between the sender and receiver, but rather the network is connected by radio waves to produce communication. Here are some of the applications of the wirelessly controlled DC motor, such as Wi-Fi systems, security systems, cell phones, and medical areas as well. A DC motor is an electrical machine that converts direct current electrical power into mechanical power, and most types produce rotary motion. The wireless control of a DC motor involves the design and implementation of a microcontroller-based control unit to use the radio frequency to wirelessly control a DC motor. DC motor also have played a vital role in the development of industrial power transmission systems. It was the first practical device to convert electrical power to mechanical. It's widely used as well because of its straightforward operation characteristics and flexible performance. Also, it has been used in other fields such as military drones, surveillance systems, and toy cars. Compared to other wireless communication networks such as GPRS and GSM networks, RF, the radio frequency, is way cheaper and reliable, with a guaranteed data delivery. The radio frequency in any frequency within the electromagnetic spectrum associated with radio wave propagation when an RF current is supplied to an antenna, an electromagnetic field is created that then is able to propagate through space. Also, many wireless technologies are based on radio frequency field propagation. Here are the components of a wireless DC motor. The components of the wireless system to control the functioning of DC motor are listed below. First, we get the microcontroller circuit. Second, we have the pulse width modulation, H-bridge, and radio frequency model. The pulse width modulation is used to generate high and low pulses that vary and thus control the speed of the motor. It's also a modulation technique used to encode a message into a pulsing signal. Also, the PWM switching frequency has to be much higher than what would affect the load, which is to say that the resultant waveform received by the load must be as smooth as possible. Here's the diagram for the H-bridge is an electronic circuit that enables a voltage to be applied across a load in either direction. These circuits are often used in robotics and other applications to allow DC motors to run forward or backwards. Basically, the function of the H-bridge is to achieve the direction control. Here's a diagram showing how an H-bridge can change direction. The RF models are widely used in electronic design owing to the difficulty of designing radio circuitry. Good electronic radio design is notoriously complex because of the sensitivity of radio circuits and the accuracy of components and layouts required to achieve operation on a specific frequency. On the other hand, the radio frequency model, a small electronic circuit used to transmit, receive radio wave, where transmitter transmits the signal while receiver receives the signal of the same range of frequency. Here's the transfer function. Here's the transfer function on the left, and on the right side is the diagram for step response. The advantages of a DC motor is the speed and direction control from a remote place. The system has high sensitivity and not much sensitive to the environmental changes. The system is reliable and inexpensive. The control unit can control a DC motor over a long distance. Also, the hardware and software components required in the system implementation are locally available. Thank you.